Well, so as David mentioned, I'm the lead for transformation, the transformation initiative now. It's moved from an objective to an initiative. And so what is it about? It's about accelerating the transformation of systems engineering to a model-based discipline. So it's all about model-based. There's many dimensions to transformation that we'll talk about, but we only got 15 minutes, so we're going to talk at a high level. Of course, we've had the workshop, and we're going to get into a lot of details there. During the Q&A, I'm going to ask a few people that have been part of a core team to come up and participate in that, so you'll see who they are, and you can talk to them throughout the IW when you bump into them. I think we're at a very exciting time in our discipline of systems engineering. I think it's actually a pivotal time, not this week or month, but in the next several years. There's so much going on contextually around us where we can add significant value, hence the title, The Essential Discipline for Digital Transformation. Many have heard of this much larger digital transformation, right, of business and industry, this move to Industry 4.0, the Industrial Revolution, this projection of the next Industrial Revolution. So what I'd like to talk about is what is the role of systems engineering in this next big shift. When I've looked at a lot of the research around digital transformation through different consulting firms and the World Economic Forum, Forrester, Gartner, and some others, they talk about digital transformation. The real impact is when you transform the value-added part of your business. So they might talk about getting closer to the consumer, talk about enterprise systems and efficiencies that we can get through digital technologies, but not many really point at engineering. And I would submit to you that if we digitally transform engineering, the system of innovation, that's probably the most value-added part of just about any business. And so what is our role in that, and how can we help that? I think we can play a significant role. Jack Welch said, when the rate of external change exceeds the rate of internal change, the end of your business is in sight. That's my return on investment chart right there. All right? We intuitively know that's true. We know we need to respond. We need to do something different. Here's the context: complexity. Internal to our systems, we can talk about the number of components in our systems. We can talk about lines of code. External, we can talk about the Internet of Things and how we're connecting to so many other devices, systems. We can talk about the complexity within our organizations and enterprises. In the lower left quadrant, that's the Google Trends for digital transformation. So that's really expressing interest in digital transformation. It's a pretty significant change. And that's from 2013 to today. And then, of course, the last chart there, which we've seen Gary share, and it's in the INCOSE handbook, is technology adoption. How quickly are our systems being adopted? Very rapidly. All the more important that we get them right. Even Christopher Alexander 50 years ago said that, trial and error is an admirable method, but it's just real-world trial and error we're trying to replace by symbolic method, because trial and error is too slow and too costly. So that's 50 years ago. What is symbolic method? It's models. So we need to be modeling our systems. I asked Ali Dweck about the journal, and he looked across many journals, and I asked for the term model-based. How much has it been used in the key terms? And you can see the overlay on the complexity chart in the upper right. So that's kind of tracked with the system complexity that we're seeing all around us. Recently, just in August of last year, there was a Wall Street Journal article by Stephen Cohen, who's an economist. He made reference to models will run the world. So this isn't just inside INCOSE. Of course, we're seeing model-based ideas and shifts and movements in many different disciplines in many different areas. He made reference to another paper that was done in 2011 by Anderson, I think, and he made reference to if software ate the world. And he made reference to Netflix and Facebook and LinkedIn, and he was very bullish on these are good investments. Well, he was right. Many people were a bit shy because of the tech bubble and things of that nature. But Cohen's point is that models, there's a lot of hype around artificial intelligence, data science. It's not just hype. There's a lot of great things about it. But he said that models underpin them. And if we think about that, they really do. Models of all kinds. And then he made reference to the fact that if we get more data off our products and systems, we get more input about the market, we can then get better models. And as we get better models, we can get product out quicker. We can make adjustments to customer demand or needs or desires. And so this ends up being a reinforcing loop. So I drew this causal loop diagram showing about just rapid learning in market growth. And that's where we want to get. We need these closed loop models, right? Often we have models that are in isolation that help us with one thing. As systems engineers, we're very familiar and understand we need to iterate. And so as we have models that are closed loop and they span over disciplines, they span over organizational boundaries and things of that nature, we really get a lot of power. His last point was that what's the next thing? Well, talked about what's next, processes that constantly improve themselves without the need for human intervention, kind of looking out. So are we there? Are we close to that? How much are we using contextually? We need to have value and fitness in the environment, right, the business environment. So we can talk about data-rich environments, hyperconnectivity with the Internet of Things, artificial intelligence, cyber-physical systems, the security issues associated with them, high-performance computing, Industry 4.0. How much are we leveraging the technologies that are out there to really transform systems engineering? Often when I think and see people using tools, I think that we might use just 20% of what the capability is. Who feels they've really integrated these technologies and means and ways into their systems engineering environment fully? We're still in a very traditional kind of document-centric, shifting to model-based, and we're going to have to make a big shift. And part of that shift, and part of the paradigm shift, is really going from what we have focused on for some time, which was process, to the content of the systems models, right? The information that we produce and consume with the systems engineering processes. Well, you don't need to rethink or redo ISO 15288 and all that we've learned over time. We need to leverage that to the greatest extent. But we need to be thinking about what's the key system concepts that we need to fully populate and understand the data and information on our systems. And so there's been a lot of efforts and work, and I'm not going to get into that, but of course there's System LV2 that's working and looking at a new underlying meta model. There's activities, ST4SE, systems, semantic technologies for systems engineering with JPL and the CERC and others. So there's a lot of activity in this space, but we do need to have a strong understanding, strong underlying meta models. And then automation. Often, the problem is we do this in just the reverse order. We go for automation first, then we think about process, and then we think about the real engineering content, right? The mathematics, the physics, the chemistry, and all that goes into it. And we need to have that at the forefront of our minds. Next, this is ISO 15288. I know you can't read it, but those are all the process areas, right? Lifecycle management process areas. It provides a good framework for us to think of the purpose of our models and what we're doing with them. Also, there's a graph there that you can see. Quickly graphed the n-squared matrix at the back of the handbook. And if you see the most central large node there with highest degree is knowledge management. May not be what you thought it would be. But we need to be thinking about how do we record information? How do we reuse our models? That's where there's a big, big, big leverage, is when we reuse our models. We have patterns. We get into the ideas of things that were shared yesterday on patterns with Bill Schindel, or even in model curation with Donna Rhodes that she shared about. There's a lot of things that we need to do in this knowledge management. Because where is the knowledge right now? I don't know how many people have seen Moneyball or read the book from Michael Lewis. It's a great, great work. If you haven't, I recommend it. There's a tension between subject matter experts and analysts. I think we've probably felt that ourselves, right? And they're trying to determine who do they draft. And what we're trying to do is we're trying to take tacit knowledge that we've learned over many years and encode them into models. And that's why we need to have a really robust representation of the information so that we can properly record what they've learned. And so we need to work through that tension. We need to work with our colleagues to help build those models. A reference to Vision 2025, one of the things I really liked was this idea of where we're going from. Of course, document-based approaches, still in the early stage of maturity, there's a lot of limitations. But the from and the two is shared human understanding. Our models are to inform one another, right? Often right now when we do system models, it's a core team, it's quite small, that get really rich understanding of our systems. But it's not propagated to the much larger, broader community, and that's what we need to do. We need to be able to communicate these models so that we get that shared understanding of our systems. The triangle there is actually from the Army, and it's just showing from data to information to knowledge, and then shared understanding, something that we all probably are familiar with from a knowledge management perspective. So what does transformation look like? It's not continuous improvement. It's not a small change. We're talking 10 times, 100 times, 1,000 times. One of the things I like to say is months to minutes. Can we get there? Months to minutes is in the order of 30,000 times. I think we can. Here's another view of transformation. Is that what our discipline's looking like as we try to transform? I don't think so, not quite yet, right? I think we're making progress and we're really close, and that's why I say I think we're at a pivotal time. It's a paradigm shift. The previous state is unrecognizable. I hope that soon we look back and went, we did what? Why? Why did we do that? Okay. And then it doesn't happen overnight. It takes time, it takes effort, it's painful. There's a lot of work involved. Gartner's hype cycle is a great way to think about where we are, right? If we look across the bottom, you can see there's a technology trigger. This is really just an overshoot in a control system in a way, right? We're all familiar with that as engineers. Technology trigger, hey, model-based systems engineering is going to solve all your problems. So there's this peak of inflated expectations, not realizing, no, this is hard. We got to really understand our systems and get to the physics of things, right? So then they get into this trough of disillusionment. We got to work hard. And then there's a slope of enlightenment, this plateau of productivity. And I think that that plateau actually is very high once we get this information in the right format and structure and content. So you have to think about, where are you? I think you can think about this from an individual perspective, from a program perspective, from an enterprise perspective, even from a domain perspective. You can plot where you're at. And I think it's a good thing to do that. Geoffrey Moore's Crossing the Chasm is another really good framework or way to think about it. From innovators to early adopters to pragmatists. The pragmatists who are kind of say we don't like those people, kind of navigate by the force. This is a great thing, show me, right? It overlaps, so where would you put where you are today? Personally, I think that there's been a shift. At least I'm sensing it. And I think that we're going to sense things a little advanced of where I think others will. In a way, we're the change agents. We're the ones who are moving forward with this or trying to press this forward. So we might see it maybe that we're in the early adoption, whereas others are going to say, no, you really have a technology trigger and you haven't convinced me. It's interesting to note, too, that over 80% are followers or laggards. That's pretty significant. We have a lot of convincing to do. Another aspect of that, McKinsey pointed out that over 70% of transformation efforts fail to meet objectives. That's another significant thing that's in our way, right? So early on, a couple years ago now, we created this matrix that says really what we want to do is systems engineering is acknowledged as a model-based discipline. We've heard different leaders at different times talk about that the MB, we want to just fall away, and it's just known that systems engineering, that's what we do. I don't think we're quite there yet, but that is the vision and where we want to go. The mission on this is really the objective. INCOSE accelerates the transformation of systems engineering to a model-based discipline. That's what kicked off this effort. But you can see there's 3 areas and work streams. Internal to INCOSE, we've been looking at some things. How do we better infuse INCOSE, even through certification, through the CBOC, through the handbook, through standards, through a lot of the various things that we do. Our working groups, engaging stakeholders, going out, talking to companies, talking to organizations, other INCOSE chapters, and then advancing the practice, trying to see where we have gaps within INCOSE and trying to then match and get some things going in that area. So we are 3.5 years or so into the objective of a 5-year objective. We've now moved to an initiative. We've got some time. I think we have a lot of work to do to start to shift a lot of our ideas into real products. And Mike Celentano has done great work to try to formalize that process, and we're going to go through that and develop products and try to get those into your hands. So some of the outcomes achieved, this is a long list of many things, but we've supported the incubation of 7 challenge teams through the MBSE initiative. That's probably one of the more significant activities. Some of those have become working groups. We can think of digital engineering information exchange. We can think of patterns that went from challenge team to a working group. Also augmented intelligence and systems engineering, and many others. Provided in the last about almost a briefing a month, be it visiting companies, sharing about this, calling chapters, going to regional events, and briefing transformation and model-based systems engineering, trying to get the word out and understanding. Lastly, is this idea that Cotter, who talked a lot about change, he's got this 8-step process, and then recently he had a book, Accelerate, where he talks about this dual operating system. Many of us are in very large organizations, very structured, like that hierarchical chart, that starts working toward efficiencies, and we lose this idea of this organic kind of innovative thing that you might see in the graph. It's kind of light there to see. But we need to have that organic, innovative aspect with a shared vision of where things can go that also works across and through this more structured area. But what's really important is the first step, creating a sense of urgency. I think we need that now. We need a sense of urgency within our organizations when you look at those charts of the rate of change, what's going on all around us, and the opportunity that's really in front of us within systems engineering. So I do believe that systems engineering, my assertion, is that it is the essential discipline for digital transformation. It's a cohesive discipline, multidisciplinary. It's pulling in and trying to work with all the various models that we have across a life cycle, across various functional disciplines, organizational boundaries. We have a very, very difficult challenge to do this. But if we do it, I think that it empowers all those other various technologies that I mentioned previously. Lastly, Edwards Deming mentioned, it's not necessary to change. Survival is not mandatory. Right? Another return on investment chart. I've talked to folks at different times and said, you know what, we can do this in INCOSE, and I think if we do this, we're going to come up with a robust solution about how we deal with cyber-physical systems, the key and important information in it. If we don't do it well, companies are going to find a way to do this. It might be IT solutions and just wiring things together that don't follow patterns, that don't follow standard interfaces, that don't follow core system concepts. And it ends up being brittle, it ends up being expensive to maintain. And so I think we really got to get this right, and we got to get it out there to help the broader community. So there's also a call to action, and that call to action is to join us, to work with us. Please, we've got a lot of products that we're trying to work with. Would like your input, would like your participation. Please reach to me, and then we can move to a Q&A. And during the Q&A, I'm going to ask Jeff Bergenthal, Bill Schindel, and Mark Sampson to come up and join me for the Q&A period. There's also many others who've participated and helped with this, starting working groups, challenge teams. David Long's worked with us, advised us on different things, John Thomas at times, Sandy Friedenthal. So there's a broad group of people that have really kind of helped. So with that, we can go to a Q&A.